definition, we can say that as a opposing force. Potential is nothing but a kind of opposing force. Let's take, so I'm giving that, I'm giving you some, the physical interpretation, how to imagine the potential. So actually, in science, so you cannot feel the potential, you cannot see the potential. That is the problem. Okay. Okay, you cannot high friction. What is friction? So you cannot feel the potential, you cannot see the potential, but you can so observe how it is going to be. For example, now I'm taking the flow of water in this side, this direction. Okay, this is my flow of water. Okay, so what you will say, so this is the one bank, and this is the other side of the bank. Okay, your water is going like this, or your floating is like this. So what you will do, you wanted to drive a boat from this position to this point, this side, like this. So what you have to do, so your water is floating in this direction, you have to push more pressure or more force to move your boat this direction, or else you have to tie with your boat with a thread like this, with rope, and you have to pull the rope this direction. Okay, then your boat will move in this direction. So are you fine? If your flow of water is moving very fast, so at certain point maybe you can come like this. So at certain point only your boat will be stay, maybe your boat will stay up to this point. So beyond this point you cannot able to pull your boat, because your water is floating more. So that's why may you can come from this position to this position, but after this position your boat will not move. Okay, but here you cannot see.
Good, sir.
Okay, you cannot see or you cannot feel any force, any pressure from the water on your boat. But when you are pushing, so when you are pulling your rope, or when you are pushing your boat, you will feel some amount of force, you will feel some tightness. So that tightness you can call it as a potential. Got it? So why I'm explaining this kind of thing? So in charge also, so in the electric field also, if your electric field direction is this side, okay, okay, so I'll not go for electric field, just I am taking a charge q. So charge q has electric field up to this point, like this. So this is the, so equipotential surface up to this point. So what you will do, so there is a charge somewhere you kept here, this is the called and test charge. The test charge I kept here. So what you are bringing, so usually you will bring that test charge like this. Okay, you are bringing here, but when come to here, okay, your test charge will repel each other due to that positive repel each other. So may you can use external uh, force to bring your charge from this position to this position. If you wanted to bring your charge inside of the this charge, okay, at this point you have to give more force, you have to give more force, but you can come up to this point, you cannot come up to close to the charge because it will oppose each other. So means when you're coming your charge from this point to this point, you will feel some kind of repulsion. Okay, so you are avoiding the repulsion, you are bringing your charge to this position to this position. So what you are felt opposing, whatever it is called, that is called potential of the charge, potential of your test charge only, not this charge. I'm asking, I'm saying the potential of your test charge. Potential is nothing but you need some certain amount of invisible force or whatever it is to bring your test charge inside vicinity of your charge. That's it. This is the concept of the potential. What is happening in the group? Yeah, it's not, we cannot say that opposing force, and it's kind of opposite, it will be opposed. Okay, so that's why we are forcibly we are pushing forcibly we are pushing the charge towards the vicinity of the source charge, then you will feel some kind of opposing. Okay, so that's we have to call the potential. So that's why potential we cannot imagine. Okay, but you can, when you're explaining that from certain examples of from your life experience, you can see. Okay, let's discuss about the electric potential. Today topic is on the electric potential. Today topic is electric potential. So if you wanted to know that electric potential, first we have to know work done. Work done by the charge. Sir, how the work done by the charge? So if you remember it, at the beginning of the class, I explained that. So your electric field is in this direction. If electric field is in this direction, okay, there is a test charge. I just kept it here. Okay, and this is a test charge Q. What I'm doing, so this is my initial point and I'm bringing my test charge from here to some position here. This is the F. So it is having some displacement, right? So what is work done? Sir, work done is equals to force into displacement, sir. Yes, force into displacement. So here force. What is the force? Electric field is moving in this my electric field is in this direction. So when my charge is moving from this direction, you can feel that there is a force acting in this direction. Okay, the force is equals to what is? Force is equals to charge into electric field. So just apply charge into electric field, right? And it's a dr. So here, in which case you will feel that, so this direction is opposite direction, that's why it's a negative. So work done is equals to minus q into E into dr. So this is work done, and what is work done? Work done by the charge. Work done by charge and in electric field lo, electric field is pushing this side. I am bringing my charge from this side to this side. ఇక్కడ నుంచి ఇక్కడ మూవ్ అవటానికి సో ఎంత వర్క్ చేసింది, దట్ ఈస్ గివెన్ బై దిస్ ఫార్ములా. సో యూజువల్లీ వర్క్ డన్ పర్ చార్జ్, ఈ చార్జ్ వల్ల జరిగింది పర్ చార్జ్, పర్ యూనిట్ చార్జ్. సో దట్ ఈస్ గివెన్ బై మైనస్ ఇంటిగ్రల్ ఇంటూ dr. So this is nothing but potential. This is nothing but potential. Potential is nothing but how much of amount of work is done by unit charge, per unit charge, and per unit charge. So that is called potential. So what is the potential? Potential is work done per unit charge is called potential. So potential is represented V. I can written as a work done by charge and raskovachu, or else I have to write integral E into dr. So this is the potential. This formula is very important, and this formula is very, very important. Okay, sir, I know potential, sir. Yes, if you know potential, you can find that your electric field is equals to minus dv by dr. This is the second formula. This is also very important. This is the second formula. Okay, and see here actually, so I forget to give you that limits. So if I take the position, this is my initial, this is my initial position, and this is my final position. This is my initial position, this is my final position. Is this understand, right, the potential concept? Next, so take one example or two example. I will give you one example based on the formula. If electric potential V at any point x, y, z, all in meters, in space, is given by 4x square volt and he is asking 1 minute. He is asking calculate the electric field. Sorry for the disturbance. Calculate the electric field at the point meters. So here he is asking to find the electric field. Okay, the potential is given 4x square. He is asking to find what is the electric field, and he is given that point. So what is this? 102. So how we can find that electric field, sir? Electric field is given minus dV by dr, sir. Yes, usually this is the, they are given the x, so that means they are given the potential in xyz. That means my electric field should be some xi cap, some exi cap, eyj cap plus ezk cap. Okay, but here they are given v in terms of x. That's why I have to write this one dv by dx minus, what is the potential, sir? 4x square, sir. What is the answer? It's a minus 8x. So let's find ey. Minus dv by dy, it's 0 because v is in terms of x, and which is variable is in terms of y. That's why sorry, that's why it's 0. And also ez is also minus dv by dz is equals to 0. So electric field is equals to, electric field is equals to exi cap, eyj cap, ezk cap. So those terms are 0. What I got? Ex. What is my, I'm sorry guys. Yeah, what is my ey? Ey is equals to minus 8x I cap. What is the x value? X value, sorry, x value is 1. That's why my electric field is equals to minus 8 I cap. Is this understanding for everyone? Any difficult? 8x, yes, Prajwal Gandhi. Yeah, you know, see, I got a viral fever and I was under medication. Yes. Next question. Second question. Please take the second question. Find the potential So between the points A and B in an electric field is given. Write the electric field. Electric field is equals to 2I cap plus 3J cap 4K cap and Newton per coulomb, where position RA is given I cap 2J cap plus K cap and RB is given 2I cap J cap minus 2K cap, which are in meters. Okay, he asking that find what is the potential difference. So take the formula. What is the potential? Potential is equals to integral E into dr. Okay, so this is not initial position, and this is the initial position. This is the final position. Okay, so this is the initial position and this is the final position. So let's substitute the values. V is equals to minus integral. What is the initial? Initial 2 comma 1 comma minus 2 RB, and what is the final position? Sir, 1 comma minus 2 comma 1. What is the electric field, sir? 2I plus 3J plus 4K dot product. And what is the dr? So dr we know. So dx I cap, dy j cap, and dz k cap. It's a position vector. So that's why I'm writing dx I cap plus dy j cap plus gz k cap. So what I will get here? 2 comma 1 comma minus 2. So 1 comma minus 2 comma 1. What is the value? So 2 times of dx plus 3 times of dy plus 4 times of dz. Can you do integration? Can you tell me what is the answer here? Can you please do the integration? Tell me the answer. No. Why no? Yes. Can you please do the integration and tell me the answer? See, Andy, just do the integration. How to do the integration? This one. So minus 2 comma 1 comma minus 2, 1 comma minus 2 comma 1. So 2 times of dx and integration of 2x. Sorry. I'm doing this side. So integration of 2 dx, 2x plus integration of 3 dy, 3y, integration of 4 dz, 4z. I got 2 comma 1 comma minus 1 minus 2, sorry, and this is the 1 comma minus 2 comma 1. Now substitute the limits. 2 times of x lo x limits substitute చేయాలి. Okay, so 1 minus 2 minus 1 plus 3 times of, so y minus 2 of minus 1 minus 3 plus 4 times of, so 1 minus of minus 2 3, so minus 2 minus 9 plus 12. How much you got? You will get 1. What you will get? You will get plus 1 plus 1 volt. Actually there is a negative sign is there. There is a negative sign is there at the beginning. There is a negative sign is there. So that's why my potential is equals to minus 1 volt. Is this understand? Everybody? Please tell me. Yes. Yes, Gandhi, 1. Minus 1 and actually. Yeah. You have to put the 1 is there. Everybody's understanding this concept, potential concept? Yes, thank you. So I'm giving you one homework, Andy. Same problem. Please try to solve it at the home. The same. Find the potential. Sorry, find the potential difference VAB between A is given to 10 meters and B is given 0 to 4 in an electric field. Electric field is given xi cap minus 2y j cap z k cap. Okay, so options are minus 3 volt plus 3 volt, so minus 2 volt, none of the above. ఓకే, ప్లీజ్ ట్రై సాల్వ్ ఇట్. ఇప్పుడు మనం ఈ ప్రాబ్లం ఎట్లయితే చేసామో సేమ్ అండి, సేమ్ లైక్ దిస్ ఓన్లీ వీ హ్యావ్ టు సాల్వ్ ద ప్రాబ్లమ్స్. లెట్స్ నౌ come to the most important topic, applications. This is the most important applications. Today we are discussing few applications and tomorrow we are going to discuss the important application also. Okay, applications. So about what application? Applications about the potential only. The first application. Now I have to find that potential due to a discrete charge. So discrete charge. So careful observe, జాగ్రత్త గమనించండి. If you understand this concept, then all potential is going to be easy for you. So there is a charge. This is my charge Q. Okay, I wanted to find my potential at certain point P. I told you at the beginning only. If you observe carefully, at the beginning, in this case, what I told you, in this case I told you, oh sorry, I removed that way. Okay, wait. At the beginning I already told you about. So potential. So in my test, this is my source charge. My source charge has the electric fields like this. Okay, it will form the equipotential surface. This is the equipotential surface. Okay, so when I wanted to bring some test charge, and my test charge will come up to this point only, it will not come. So this I am saying that it has some visible repulsion. That repulsion I am calling it as potential. So this potential I am not saying about the test charge. I am saying this repulsion, invisible repulsion, is due to this charge Q. So that's why, so this charge has that much of potential. So that potential he helps to this charge to not bring the other charge inside this vicinity. So the potential is due to this charge only, not about the bringing charge. The bringing charge is a test charge. Why you are bringing the test charge? To determine that how much potential having my source. Okay, so if it is Q, it has more a little bit potential. If it is a 2Q, more potential. 3Q, more potential. So how I can check? I need someone na to check that. Arey yaar, your friend is pushing me like this. So మీ ఫ్రెండ్ దగ్గర చాలా బలం ఉందిరా అని చెప్తాడు. So similarly like this, I am bringing the some source test charge here to determine that how much potential I am having the source charge. Okay, do not think that this potential is that test charge. Here also I wanted to find that potential to this charge, not this charge, but I am bringing the charge somewhere to up to this vicinity. Okay, so up to this point. So if I wanted to find that potential, I need first electric field. What is the electric field for this charge, sir? KQ by R square, sir. Yes, What is the potential? Use the formula of potential. V is equals to integral E into dr. Okay, integral. What is the E? Sir, kq by r square. Okay, into dr. Now see, observe, there is a somewhere my test charge is there. Now I'm saying I'm bringing my test charge from there to I'm bringing there. So what is happening? ఇక్కడ నుంచి నా టెస్ట్ చార్జ్ is coming very fast. Oh, sorry. From here my test charge is coming very fast, it's coming very fast. So when I approaching to the vicinity of the this test charge, sorry, or source charge, so my test charge is coming very slow. It's not moving, it's moving very slow, slow. At last it come up to this point. So beyond this point it will not move, because now it has the power, so it will not enter the test charge. Maybe it will come fast because now there is no electric field at this point. So when it's closing to the electric field, my source charge is opposing the test charge. Hey, you not come to my vicinity, you not come to my region. Okay, idanta na atta antunna. So that's why this particle is coming, it is coming up to this point. So in any circle, if you draw a circle radius like this, in this area the test charge will not come. That is called potential. It is coming up to this point. So this is the initial point and this is the final point. So initial point usually we will take it as infinity, endukante it is beyond so between this distance, when compared to this small r, it is a very large distance. That's why infinity initial point usually we will consider as a infinity. But final point, what is the final points are this distance r. ఎంత distance లో ఉంది? ఇది q నుంచి r distance లో ఉంది. So that's why my initial is taken as a infinity, final is taken as a r. Is this understand why I taken this infinity? Now find this kq I taken, so minus 1 by r square. If I make integration, it's a r by infinity. 1 by infinity is 0 nandi, it's not infinity, please careful. kq by r substitute చేస్తున్నాను, so minus 1 by r. So this is r and not r square, 1 by r. So the potential due to a discrete charge, a single charge, is kq by r. What is the velocity? Oh, kq by r square. What is the force? kq1 q2 by r square. Okay, you have to know this difference. ఈ మూడు మీకు డిఫరెన్స్ తెలియాలి. This is the potential. Is this understand? This point understand for everyone? Why I am explaining this clear concept is very important. This Tejax, you did not understand? Okay. Which part you did not understand, Andi? This potential concept, what I explained? Potential due to discrete. Please tell me, please let me know which part you didn't understand. Potential due to discrete charge. Please, Tejax. Okay. See. Yes, not understand. Okay. See, చూడండి ఏం లేదు. What you are finding, we are finding the potential due to this charge. Okay. So this charge has the some electric field up to this range and r, up to r. What I'm doing, I'm bringing a test charge from infinity distance to the close to the r. So my particle is stayed somewhere here and it is stay up to here. So what is the electric field at this point? Sir, E is equals to kq by r square. Fine. So what is the potential definition? Potential definition is equals to integration of E into dr. So in the place of E, substitute the electric field kq by r square dr. So I told you at the initial point we have to consider it as a infinity. Infinity is a reference point for the test charge in the potential concept. So that's why initial I take in infinity, Finally, I have taken a r. So distance from the my charge. So I have done the integration. So 1 by r square integration is minus 1 by r. So it's a infinity and r. If I substitute infinity, I will get 0 minus of r, 1 minus 1 by r, right? Minus 1 by r, I got. So minus minus plus kq by r. This is the potential due to the discharge, discrete charge. Is this okay, Andy? Shall I explain again? యా సి నేను ఇంతసేపు ఎందుకు ఎక్స్ప్లెయిన్ చేశానంటే యూ హ్యావ్ టు కన్ఫ్యూజ్. సో ఐఎమ్ సారీ, యూ షుడ్ నాట్ బి కన్ఫ్యూజ్. సో యూజువల్లీ వెన్ ఐఎమ్ స్టడింగ్ ఇన్ 12th standard, I always thought that the potential is due to not this point. I thought potential of this charge, test charge. నేను ఎట్లా అనుకునేవానంటే okay, we are finding the potential for the test charge. No. That was no wrong understanding. That's why I explained this. If you understand this concept, if you wanted to find the work done by the different particles, single particle, triple particle, combination of the particles, then you have to use this potential concept very clearly. If you not apply the clear potential concept, you will be get wrong the answer. That's why I explained this concept very, very slow. Okay, now move to the next application. Application number 2. This class we are going to take applications only, and potential due to system of charges. Okay, potential due to system of charges. So let's take, I have a number of charges plus q1 at this point, so plus q2 at this point, plus q3 at this point, and minus q4 at this point, and so on. I'm saying I wanted to find the potential at this point. Okay, so the distance from this point to this point, and this point to this point, and this point to this point, this point to this point, and there is some charge like this. I'm not considering that charge only, just I give it. There are so many charges like this point to this point. So potential is nothing but the total potential is equals to potential due to v1, charge v2, charge v3, charge v4, and so on. What is the potential due to q1? Sir, ipude ka sir meer explain chesindi r. This is the r1 and this is the r2, r3, r4, so on, rn. R1, sir, yes. So kq by kq1, kq2 by r2 plus kq3 by r3 minus kq4 by r4 plus so on. So usually I can write in general, how I can write my potential is equals to summation of k qi by ri, where I is 1 to small n. This is the potential, combination of the potential. If they're given system of the particles, charges, if they wanted to find that potential, this is the combination of the sorry, this is the potential due to the all the system of particles. Is this concept clear? Is this concept clear? Yes. Yes. Now next application. From this, very important, and be careful, listen. Potential due to a circular ring. This is the very important. Okay, just take, I'm I'm taking a circular ring and sorry, I got usually I have a fever. 1 minute. Sorry, guys. Yeah. So we have to find the potential due to the circular ring and so this we already know circular ring has the radius r. Okay. I wanted to find the some potential due to somewhere here. Okay, at the point. So how I can find that potential? I have to take the test charge some at the point of infinity. I'm taking the test charge here. What I'm doing? So my ring has the electric field up to this area somewhere. Okay. So my I'm bringing test charge very fast, and then coming to close, it's becoming very slow, 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 and it came here. Okay. Someone share the screen and what happened? Why are no? I was under medication, Doyajax. I'm not taking lunch. I was taking bread only. Okay, okay. We'll start the class. So in this only we can find that potential, right? So I brought that my charge somewhere at the point from the infinity to this point. So this is my potential. Find the point. But what is the potential formula? Potential is equals to integral E into dr. This is the initial, this is the final. Initial we know infinity నుంచి మనం తీసుకొస్తున్నాం. Final ఏంటి? So this distance r. Okay. But మనకి ఏం తెలియాలి? E value తెలియాలి. What is the what is the value of E? Electric field. So due to a ring, what is electric field due to a ring? Sir, electric field due to a ring, you are given K Q R by R square plus R square 3 by 2. So there is a charge on this like this. Okay, let's substitute this in the potential. Potential due to ring is equals to minus integration. So K Q R divided by R square plus R square into dr 3 by 2. So this is the infinity and this distance is r. Okay. So V ring is equals to so minus KQ integration plus infinity to r by r square plus capital R square 3 by 2 into dr. We already know what is this formula. Integration of r by r square plus a square whole by 3 by 2. Sir, negative, sir. Yes, negative. R ఉంది కాబట్టి we have to remove that r. Minus will come 1 by r square 1 by 2 integration infinity to r. Okay, the term will be going to be 0. That's why what I got minus minus will get negative, positive, and kq divided by r square plus r square 1 by 2. This is the potential due to a ring. This is the potential due to a ring. Is it difficulty? Is it easy? Have we find any difficulty only? What is halwa andi? What is happening in the chart? Infinitely long wire has the uniform line charge density lambda. Net flux to the Gaussian cube length is root 3 centimeters. So the wire passes through the any two corners of the tube. The maximum displacement of each other would be. So Toyajaksh, this kind of problem I already explained and in the class. So this is a similar problem. Yes, yes, thank you. Rocket science, not rocket science, science of rocket. See, Toyajaksh, please see. You guys have to try and at least try cheyandi. See, I think according to that diagram, what I understand in the chart box, lo Toyajaksh problem పెట్టారండి. So he told that he is given like this, and they are given some line charge distribution like this. Okay, so what you have to do? So outside of this, okay, outside this area, it will not contribute. This part it will not contribute the flux. Only this part only it will contribute the flux. It will go like this. Flux will go like this. So I already explained this kind of problem. You have to change this into lambda L. Okay, do like this. Try it. If you not get it, and you can ask me. Okay, don't worry. And fine, and like that you have to find that formula. That's it. The same method we have to find. Is this understand for everyone? It's a simple thing only. Now let's find the another application. Oh, the another application, the fourth one. So potential due to circular disk. Due to a circular disk. Okay, let's take circular disk. Consider a circular disk. Sir, this is a circular disk, sir. Yes, and so it has a charge distribution, and it has some sigma. Okay, and also charge q. So the radius is r. The radius is r, and you're asking to find my potential at this point. What is the potential? What is the potential? First, we need, if you wanted to need a potential, what we need what is the electric field. What is the electric field? And so due to this disk sigma by 2 epsilon naught, మీరు ఈ ఫార్ములాస్ రిమెంబర్ పెట్టుకోవాలండి. in all formulas are given in the class at the board. You have to remember this formula. 3 by 2. Okay, let's substitute these values. Potential is equals to, so this is the disk and the electric field due to a disk. I am finding the potential due to a disk, minus integration infinity to r sigma by 2 epsilon 1 minus r by r square d by 2 into dr. Okay, so I written directly, no? Sorry. Potential is this and I forget to give formula. Potential is this one. Initial to final. Okay. In the place of E, I substitute this one, and this is the dr. So potential due to a disk. So now find this. So minus r. Okay. Sigma by 2 epsilon, it should be outside. Yes. And make a bracket close. Infinity to r. So 1 into dr minus integration infinity to r divided by r square d by 2 into dr. Is this difficult, Andy? We solved this problem already. You already solved this kind of problem. So potential, so minus sigma by 2 epsilon naught, and what I will get here. So this is going to be minus r, right? This is going to be minus r. No, sorry, plus r. This is going to be plus r minus of. So this is r by r square plus capital R square 3 by 2. What I will get? So minus 1 by r square plus r square 1 by 2. Okay. So now see, if I add all those things, if I multiply it outside inside, So sigma r by 2 epsilon naught and plus plus, and it will become minus. So this is become minus, and minus plus, and it will become also minus again. Why this is minus? This is not minus only. This is minus only. Minus and minus of minus. This one, what you will get here? 1 by r square, capital R square, 3 by 2. So potential due to a disk is equals to sigma r by 2 epsilon naught plus 1 by r square, 3 by 2. This is all mathematics, and there is no concept. Just you are deriving the formulas. That's it. So what you have to remember, ఈ derivation మొత్తం you don't need to remember అండి. You don't need to remember derivation. You have to remember. So what is the electric field due to a disk, and you have to remember the what is the potential due to a disk. Here ఇక్కడ కూడా అంతే. What you have to remember in this place, you have to remember what is the electric field due to a ring and what is the potential due to a ring. That's it. Sir, ఇక్కడ మీరు రిమెంబర్ చేసుకోవాలి. ఇక్కడ కూడా అంతే. ఇక్కడ ఏం అవసరం లేదు. Here you have to remember what is the electric field due to a charge, what is the potential due to a charge. These points you have to be remember. There is no derivation. You don't need to remember the derivation. In the potential, they will not ask derivation, and they will give you the formula directly. So they will ask the potential like this. They will give you the spherical shell like this. They ask to find the potential, or they will give you the spherical shell and they will give you the cavity like this, and there is another cavity here. They will ask the potential like this. So we will discuss this kind of problems. Not now. We will discuss tomorrow and day after tomorrow. Okay. So next, the fifth one. Yeah, 1 minute only. Minus minus plus plus. Sorry, Rajesh, minus minus, math is not matching. Math is not matching. Something is wrong. Sigma by 2 epsilon. Where is wrong only? Yes. Yes, sir. Yes. We cannot solve like this. See, you can take sigma by 2 epsilon naught, and so integration infinity to r, it's a dr minus integration infinity to r, so r by, oh sorry Andy, this is 1 by 2, this is 1 by 2. Yes, electric field, this is the 1 by 2. Okay, this is 1 by 2. If you take 1 by 2, the formula will be, this formula you cannot use. This is the 1 by 2. Okay, then we'll solve the problem. Yes, and sigma by 2 epsilon naught. So this is 1 by 2 only. So here r divided by r square plus r square, it's a 1 by 2. So into dr. So basically and sigma by 2 epsilon naught. Here you will get r minus infinity to r 2r divided by 2 times of r square 1 by 2 into dr. So here we can use one formula. The formula is this one only. F dash of x divided by root of function of x. It will give you 2 times of f of x. Okay. So what is that this meaning, sir? See, here I substitute the I multiplied with the 2 and divided by with the 2. So why I divided I done like this? If you see carefully, my function is this one only. If I take my function is my function of x, if I take like this, uh, 1 by r square 1 by 2. If I take like this, okay. So what I will get if I take like this, if I make derivative of this, mm, if I make derivative this, I will get so 1 by 2 square root of 2. Ah, no, no. So 1 minute. Yes, I got the answer. Function of x is equals to r square 1 by 2. So derivative of the 1 minute and the function is equals to 1 by 2 into so r square. Here this is going to be 0. And that's why what I will get here, I got r square plus r square uh, 2 minus 1 by 2 into 2r. So this will cancel. What I got here. So r by r square plus r square 1 by 2. So then I can written like this. Derivative of this function I have written like this. This is a df of x. Okay. Wait a minute. Toyajax, you should not call me Wabani Toyajax. That is not correct, Andy. Okay. That is not respectable way. You should never call anyone with their first name only. Okay. See. So here this is the formula. This formula. So here you will see this. If I take the denominator as a function of f of x, let's see like this. So this is the given the formula. Okay. So my denominator is f of x. If I consider this is my f of x, what is my f of x? R square. It's a 1 by 2. Okay. So this is the root of r square 1 by 2. What is the f dash of x? It is nothing but 1 by 2 r square plus r square and 2r. So from this, how I can write f dash of x divided by f of x into root 2. What is my f dash of x? Sir, this one only, sir. So 2 r divided by 2 times of r square plus r square 1 by 2. See, this formula is nothing but this formula. If you have any derivation like this format, you can write it directly like this: 2 times of root of f of x. What is the 2 times of root of f of x? 2 into what is f of x? This one, r square plus r square whole power 1 by 2. So in the place of all integration, this integration, okay, I can directly substitute this value. Are you understanding this? I can directly substitute this value. 1 minute, I will see. Yeah, yeah, Prajwal, you can say that Wabbani sir, but you should not call me Wabbani. Okay, minus 1/2. I will explain Andy. Yeah, explain. The next page I will explain. See, here the thing is this integration we have to do. Okay, but how to do this integration? There is a standard formula, f dash of x divided by, so root of f of x, which is give you 2 root of f of x. This is the formula, standard formula. Okay, so in this case I am having my denominator is in the form of root of f of x, right? The whole f of x I am taking as like this, r square plus r square. Okay, this is my f of x. So but న్యూమరేటర్ లెటర్ రావాలి నాకు, ఎఫ్ డాష్ ఆఫ్ ఎక్స్ లో రావాలి నాకు న్యూమరేటర్. Are you understanding? My numerator should be like this. My numerator f dash of x and it should be root of f of x. How it will can how it will become? So if I derive to f dash of x, how it will become? So 1/2 r square minus 1/2 into 2r. See, this is in the form of 2r by 2 times of r square 1/2. This is like this, f dash of x into root of f of x. See, this form is like this, in this form. I understand. So that's why here, if I wanted to get this form, what I have to keep? I have to keep 2 here and 2 here. Okay. Y minus 1/2 minus 1. ఒక్క నిమిషం అండి. I will take your question అండి. So that's why here I am taking. So for this integration, what I am writing, total integration instead of total integration, I am writing this one. 1 minute అండి. Oh, sorry. Toyajax, oh, I was mute my mic. I was sorry, Andy. Toyajax, is that you? I just talking till now. Yeah, I'm sorry. Toyajax, is that you only? See,
Yes, sir.
okay. Sorry, Andy. I'm talking. Is that you, Toyajax, or not? Please respond. I'm talking. I just kept my mic in the mute. I was, I don't know why I
Sir,
did that.
explain it last time.
Andy, okay, Andy. So, yeah, come to your point, Harshit. Okay, Andy, let's see. Now I'm taking. So usually, Andy, we have to take if I take function of x is equals to r square, and if I take like this, okay, just take a simple thing. Don't do that. What I'm giving the formula, this formula, Andy. So what is my f dash of x? It's a 2r, Andy. So f dash of x divided by f of x is equals to 2 root of f of x, Andy. Okay. So I need f dash of x. Here I have r only. So that's why what I'm doing, instead of r, I'm taking like this 2. If I multiply, if I put 2 in the numerator, I have to put the another 2 in the denominator. So this is like this is the form of f dash of x divided by root of f of x. What is the answer? 2 root of f of x. So in the place of this, what I have to substitute directly, I have to substitute 2 root of f of x, right? You just understand this concept, this one. So minus sigma by 2 epsilon naught r minus, instead of this whole term, there is a 1 by 2 is there already. So 2 times of, so root of f of x. What is my f of x? R square plus r square. So these two will cancel, and the minus sigma by 2 epsilon naught r minus root of r square plus r square. Is this understand? Is this okay, Andy? This derivation simple? Yeah. Yeah. Sorry, my explanation is too bad. Yeah. My explanation is too bad. Sorry. It's a disk. Actually, the problem, where I got the problem initially, here I have taken the electric field 3 by 2. Okay, there I got the mistakes. When I take the 3 by 2, then I applied the formula directly. But here it is a 1 by 2. Now I got that, how to do that. Okay. Okay. So next one, we have to complete the application, only. And so this is a very important concept, potential due to a hollow sphere. So ఈ hollow sphere, solid sphere మీద we are going to solve more number of problems, especially hollow sphere అండి. సో జాగ్రత్త గమనించండి. So I am taking a hollow sphere, I am taking a sphere like this. Okay, I wanted to find, usually what I done at initial, at the beginning, if this is my radius and hollow sphere has the sigma and it has a q also. So initially what I found, electric field we found. Electric field at the outside of the point, at inside of the point, on the surface of the point also. So surface of the point is not matters. We already the just r is replaced with the capital R. That's it. Here also, what you do, we have to find that potential at the outside, potential at the inside. Can anyone please respond in the chart? Is the potential inside the sphere is zero or not? Zero at yes? Yes. No. Very good. Excellent, Andy. Excellent. So why no? Now we are going to discuss that. Why no? Why it's not zero? Electric field zero అయితే Why potential is not 0? That's we are going to discuss. Now find, now I am discussing potential outside. Okay. Finding potential outside of sphere. Okay. Could you please tell me what is the electric field outside of the sphere? Sir, kq by r square, sir. Yeah, that's it. Simple. So, what is the potential? Potential outside? Oh, this is out and so integration, sir, minus infinity to r, sir. So this distance and r and a, please, I forget to write. This is the r. So r e out into dr. What is the e out? Integration into r, sir. K q by r square into dr. Okay. Now you can find v out is equals to k q by r. Okay, k q by r. This is one formula. Okay, ఇక్కడ అయిపోలేదు. So this is the one formula. మనం ఇప్పుడు Qని we have to substitute in terms of the charge density. We have to substitute in terms of the charge density. What is the Q? Sir, Q is equals to sigma into area, sir. What is the area? Sir, this is a sphere, sir. That's why 4 pi r square, sir. Capital R అండి. ఇక్కడ క్యాపిటల్ ఆర్ ఎందుకు తీసుకున్నాం? వీఆర్ నాట్ టేకింగ్ ద స్పియర్ హియర్, వీఆర్ టేకింగ్ ద స్పియర్ ఆఫ్ ద ఒరిజినల్ స్పియర్, radius of the original sphere. That's why 4 pi r square. Let's substitute. V out is equals to how much? 1 by 4 pi epsilon naught into q place lo em పెడుతున్నాను, sigma into 4 pi r square divided by r. So what is my V out? If I cancel 4 pi, what I got? I got sigma r square by epsilon naught into r. So this formula is most important, and this formula is most important. Okay, do not mistake, do not mistake, do the mistake. Now come to the potential inside the sphere. Inside the sphere, let's take sphere. So this distance is r and r dash, and this distance is r dash. Yes. So what is the electric field inside? Oh, sir, electric field inside is 0, sir. Or potential 0 avadu. Let's see how it will not be 0. Inside is equals to minus infinity to r dash. Okay, electric field inside. Okay, sorry, electric field into dr. So careful, see here, carefully observe. So from here to, so this is one point. From here to, so this point. From here to this point is another point. So how I to write? How I can write? I can write my infinity in terms of like this. I am bringing from infinity to capital R minus capital R నుంచి ఎక్కడికి వెళ్తున్నాను నేను? R dash కి. I went to R dash. So EDR and EDR. Is this understand? Why I written infinity to capital R to R dash? Please tell me. Yes. Kushi and Unaisi, మీకు అర్థమైందండి? Toya just did not understand. ఇంకెవరైనా? కుషి మీరు? yes భాగ్య. ఓకే కుషి కూడా అర్థం కాలేదు. ఓకే ఫైన్. I'm explaining in the separate page and neatly. See, this is my charge. Okay, బయట కనుక్కున్నాం, మనకు అర్థమైపోయింది. If I wanted to find that my potential at this point, so from this point, this is the R charge. Okay, what I'm doing right now, I am bringing some charge at this point. This is the point infinity. What I'm doing, I'm bringing from here to 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 up to this point. Okay, so what is this distance, sir? This distance is R, sir. మళ్ళీ ఏం చేస్తున్నాను, ఈ పాయింట్ నుంచి మళ్ళీ ఈ పాయింట్ దగ్గర తీసుకొస్తున్నాను. ఈ పాయింట్ డిస్టెన్స్ ఎంత, R dash, sir. So usually this distance we are calculating potential. Potential is equals to minus infinity to R dash up to this point. Sorry. So up to this point, we are finding up to this point. So R dash. But ఈ R dash మనకి ఎన్ని రకాలుగా ఉంది? It's like a two types. You know, it's a splitting in two way. How? So minus వదిలేసేయండి, ఇక్కడ మైనస్ లేదనుకోండి. ఫస్ట్ there is no minus, just plus one. ఓకేనా? ఇంటిగ్రేషన్ ఇన్ఫినిటీ నుంచి ఐఎమ్ బ్రింగింగ్ టు R. ఓకే సార్. అగైన్ ఇంటిగ్రేషన్ ఐఎమ్ డూయింగ్ ఇంటిగ్రేషన్ R to R dash. ఇక్కడ మైనస్ ఉంది కాబట్టి I multiplied the minus of plus, it will become again minus also. That's why I written the both minus. Is this understand? It's like a splitting of integration andi. Splitting of integration. Is arthamaindandi? Now you got that? Doyajax? Yes, please ask Doyajax. Now have you understand this? Please respond. If you understand only, then I will move. Please respond. And we have 15 minutes time only. Yes, Unaisi. Kushi, Miru? No, non-conducting sphere. Yeah, it's a non-conducting sphere. The conducting I didn't come up to this. I will discuss when the conducting topic will come. And have you understand this integration? Why I taken the integration like this? Because now next problem also you have to do like this only. That's why I explained like this. So that's why I have taken like this. Why I minus will come? Both are addition and so multiply with the minus. So negative, I will get the negative sign. So what is this? Basically R to R dash. R to R dash means inside. So inside electric field and 0. So what I got, I left with integration infinity to R. What is the E? What is the E? E is the outside and infinity to R. E is the outside. So what is this? KQ by R square into dr. So V in is equals to KQ divided by R. Is this okay అండి? సో ఇక్కడతో మనది అయిపోలేదు. సో ఇక్కడతో మన వర్క్ అయిపోలేదు. So we have to substitute Q. So what is the Q? Sir, Q is equals to sigma into area, sir. Again substitute it. V inside is equals to, what is the K? So K is equals to 1 by 4 pi epsilon naught. What is the Q? Sir, Q is equals to sigma into 4 pi R square and R. R will cancel. V inside is equals to 4 pi will cancel. Sigma R by epsilon naught. This formula is very important. What I given the formulas in the green boxes, those are important. That you have to remember. That's it. You no need to do all this derivation. Is this okay, Andy? For everyone? Kushi, you written something. It's not visible, Andy. Okay. The last concept of today's lecture. So which application it is? Sixth application. Now potential due to a solid sphere. I will give you how to solve it. Please kindly solve it. Okay. Please try to solve it. I will give you the how to solve it. I will give you the hint how to solve it. This is the solid and this is not sphere and this is the solid. Okay, na? Charge is distributed all over the inside the sphere also, inside the solid sphere. This is the solid, and solid radius is capital R. This is capital R. Okay, there is a charge Q and rho. So charge Q lo kanukovali manam potential, rho lo kuda kanukovali. So he is asking to find potential at outside and potential at inside. Okay, let's find potential outside of the solid sphere. Okay, so let's take what is the electric field outside of the solid sphere. Please tell me what is the electric field outside of the solid sphere, sir? KQ by R square, sir. Yes. Potential, sir. Sir, in the solve chestunnam, sir. KQ by R, sir. Yes, that's it. There is nothing to worry. I mean, outside. Now we have to find the inside. Inside. Now, let's see who is going to solve this. I will not solve this Sunday. I will give you the hint how to solve it. I will see then tomorrow class how many students are going to solve it. I will give you hint. Everything I will give you. Don't worry.
Sir, show the before slide.
ఒక్క నిమిషం అండి. Potential inside of the sphere. Sphere means solid sphere and not a spherical sphere. Okay, so my request, take the sphere like this. Okay, and this is the center and this is the radius. I am not finding the here. I am finding the potential somewhere here. So this distance from this point is R dash, and there is a point is somewhere here initial. So I have to find potential inside is equals to minus integration infinity to R dash. Okay, you have to split this infinity into two terms. One is from infinity to capital R to R dash. And understand this? E into dr. So what is the electric field inside? The electric field inside is KQ R by RQ. This one. Okay, this one you have to use field, electric field. This is the inside end. This is the inside. And substitute the inside and you will get the answer. There is no need to do integration. There is no big integrations are there. There is a small integrations are there. But the thing is, you have to find that for which you have to do the integration. For which you have to do the integration. You have to do the integration with respect to capital R, or you have to do the integration with respect to R dash. This is the question. If you understand this concept clearly, then you will know that which integration you have to do, which variable you have to do, capital R, small r. That's your question. Okay, and find the answer and give me the potential in terms of Q and D, and also give me the potential in terms of rho. Okay, ఇక్కడ rho substitute చేయలేదండి, sorry. So my Q is equals to rho into volume. Okay, so V out is equals to 1 by 4 pi epsilon naught. So rho into 4 by 3 is a pi r cube divided by r. 4 will cancel and pi will cancel. So V out is equals to, so rho r cube 3 epsilon into r, like this. Like this, you also try to find this one. Okay, find it in the two and bring it tomorrow and give me the answer. These two only, and that's it. There is no other thing. Is this understand Andy for you? Any doubts? KQ by R. Both sides KQ by. No, no, no. No, Andy. No, no. So answer will change, Andy. It will come in so two terms. It will come two terms. Okay. Okay, Andy. So the class is over today, and tomorrow we'll discuss that spherical shells and the potential due to a spherical shell and cavity. That concept is very, very, very important. In potential, they will not ask this kind of questions. Maybe ask or not, I don't know exactly. They will not ask this kind of questions, but definitely they will ask a spherical shell. In the spherical shell, they will give you that 2-3 concentric spherical shell. Okay, like this. They will give you 2-3 concentric spherical shells like this. They will ask to find that what is the potential at this point, or they will ask the potential at this point, or they will ask the potential what is the potential on the shell 2. Sometimes they will ask, they will give you the shell like this, okay, and there is a cavity and a hole under. Okay, there is a hole. Sorry, there is a hole here, and they will ask that what is the potential inside or outside of the this shell, like this. Sorry. So these kind of problems they will ask. This is the very, 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 very important for NEET people. This is the very important, this concept. Okay, please do not miss the tomorrow class. Okay, Andy. Okay, Andy. If you have any doubts, please ask. Otherwise, kindly you can leave the class. I will share the notes, Andy. Don't worry. Okay, Andy. Thank you. And you know, thank you, Baga Harshit, and thank you for asking concerning my health, Harshit. Thank you very much. So, Hadaleni Uru Vinitana Peru. So, what is this, Sunday? I'm not understanding. Thank you, Kushi. If you have doubts, ask Kushi. Otherwise, please, you can leave the class, Andy. Okay, Andy. Yeah. Thank you, Gandhi. I will take care of myself. Thank you very much. Take care, guys, and be careful. Viral fevers are there outside. Do not go outside and do not no wet in the rain. వర్షంలో తడవదు ఎట్టి పరిస్థితిలో. ఓకేనా? Not అండి. Toyajax is not a KQ by R. KQ by R is the one term అండి. KQ by R is the one term. Okay? You getting a acha acha. Okay, okay. OG. Okay, nice. The movie is good and actually. I saw the OG. It's a very good. Very good. I saw Pawan Kalyan in different, dimension actually. Till now, no one showed that Pawan Kalyan in that dimension. Okay, he showed different dimension like complete package only. So angry mode, calm, some affection and family entertainment. I saw Pawan Kalyan movies usually is like no, he's not comedy, yes, a good a little bit comedy. సో పవన్ కళ్యాణ్ అమ్మాయిలు వెనకమాల పడటం కొంచెం అట్లా చూశాను. బట్ ఈ మూవీలో అతను ఏజ్కి అతను ఉన్న ఇప్పుడు ప్రొఫెషన్కి ఓకే డిప్యూటీ సీఎంకి సో దిస్ మూవీ ఇస్ వెరీ గుడ్ యాక్చువల్లీ. ఐ డోంట్ నో వై నెగిటివ్ ట్యాగ్ ఈస్ కమింగ్ బట్ ఇట్స్ గుడ్ మూవీ ఈస్ గుడ్ డెఫినెట్లీ ఐ కెన్ సే ఇట్. ఓకే గైస్ సో 5 స్ట్రాంగ్ yes సాంగ్స్ ఆల్సో టూ గుడ్ అండి సాంగ్స్ ఆల్సో బీజిఎం ఆల్సో టూ గుడ్. Okay guys, thank you very much. And okay, we'll meet in the next tomorrow class. Bye, Andy.